So in this video in chapter 6 networking layers, I'm gonna answer all the inside activities in chapter 6. So first activity is IP characteristics. So IP characteristics, and then we have an instructions. Read each IP characteristic, then click to connectionless, best efforts, or media independence to indicate delivery method. So before that, we identify what is connectionless, best efforts, media independent. So connectionless is when you when you send a packet, it will be the host will able to receive it, while the best effort is it will guarantee that all the packet will be delivered without errors, while media independence is used for like fiber optics, satellites, and wireless, and used to the same packet. So we'll answer this. So no contact is made with the destination host before sending a packet. So this one is connectionless. So fiber optics cabling, like what I said, media independence is used by fiber and does not guarantee will not without errors. So this one packet send depending what type of network accesses. So media independent will send packet even destination will not able to receive it, so it will be connectionless. And then best effort is not guaranteed. So once you correct, congratulations, you have matched the IP characteristic to the delivery methods. So we will proceed to the next activity. So activity IPv4 headers fields. So we have instructions. Reach each IPv4 headers function and then click the IPv4 headers field to which it belongs. So we have versions, differentiated services, time to live, protocols, source IP address, and destination address. So it will be easy to identify. So first we will identify the IP addresses recipient host. So the IP addresses recipient host will belong to the different services to the recipient host. It will be the destinations, and then will be header versions, and then commonly referred to hop count, so will be time to live. So identify IP address heading host with source IP address, and then identifies the priority of packet, so differentiated services, and identifies the upper layer protocols. So congratulations, you have matched IPv4 headers functions to their fields. So proceed to the next activity. And then this one, IPv6 header fields. So this is like in the IPv4, so they have a different types like versions, traffic class, flow levels, payload length, next headers, and hop limit. So first, the identify the size of data portions of the project. So they have a size, so we will put this in we have a size, so hop limit, flow level, they have a length, so we'll be putting size. So when each value reaches 0, so it will be the hop limit. So identifies application and upper layer protocol, so it will be the next header. And then classify packets congestion control, the flow level, traffic class. So to suggest that all packets receive the same type of IPv6. So version is always like this format, like you can see in your phone they have a version like this format. So correct, congratulations, you have matched the IPv6 headers descriptions to their fields. So activity identify elements of a router tables and table entry. So instructions. A partial router's routing table entry and have shown each section entry identified by a circles letters above it selects the correct routing table entry selection for each output. So they have a figure here, A, B, C, D, E, F. So we'll put each the questions. So first we have D, we have B of 192.168.1, prefix of 24 and 90/3072, and D via 192.168.3.1, and we have the time 603 and gigabit 0/0. So first question, the elapsed time since the network was discovered. So this one is time, this is the time, this the time where elapsed was discovered. So we'll click letter E. So the administrative distance, source, and metric each remote network. So each remote network, so this one, letter C, because of the source and the metric. So the second one, how the network learn by a router. So by learn by the router, so we will be begin for the first ones of A, which is D, and then shows the destination network. So the destination network, it will be this one, the IP address of 192.168.1.0. It will be the destination. And next is the next hop IP address, which remote networks. Next hop, so it will be the via 192.168.3.1. So it will be D. And the next one is letter F, because the only one I cannot answer, so it will be the F, that going interface the router each destination networks. So gigabit ethernet is F is only left one. So we'll check. So you have successfully chosen the correct routing entry as described. So proceed to the next activity. So activity descriptions of router function and hardware parts. So we have instructions, descriptions of router function and hardware parts are provided. In the table, drag each router component's name to the function descriptions. So we have a description here. We have our functions, descriptions. So first we'll identify the connects routers to external networks, usually over a large distance. So it will be the one interface, because it have a connects to large geographic area. So next one, a way to remotely access CLI across networks interface. So it will be Telnet or SSH, and then connects computer switch routers to for internal networking. So it will be the LAN interface, because connect computer switches routers will be the LAN interface. So a local ports USB low speed serial connection managed will be the console. And then the last one is AUX port. So we'll check this one. So correct, you have successfully matched the router's components name to their functions and descriptions. I think this will be the last activity in chapter 6, the activity router boots process. So they have instructions. Drag each of the steps of the left to appropriate fields in the field tables. On the right, to show the router boot process order. So we have the router boot process of step 1, 2, 3, 4. We will follow that. If I will put the wrong answer, it will gonna put in the top like this one. So first we will answer the step 1. We will find a step 1. So first step 1 is to perform post hardware perform build of RAM chip. So it accept. And then the next one is to perform RAM chip, so it will be the copy the RAM, so it accept also. Then the second to the last is load iOS operating system files. The routers loaded into RAM of both strand finds ISB. So it will be the last one. The locals, the configuration file from flash and VRAM, ATP servers, or going into setup mode, create configuration file. You can see you have successfully listed the orders of the router boot process. So this is all about in chapter 6 activities, and that's all. Thank you.